Welcome back to the deep dive. Today, we are going to look at something that happens, I don't know, probably 100 million times a day in the corporate world.
Oh, easily. Maybe more.
It's an action that's so routine, so, muscle memory for the people doing it, that they don't even blink.
Mm-hmm.
You finish an order, you verify the numbers, and you click a button that says send invoice.
It feels like the most basic thing in the world, doesn't it?
Yeah.
Like sending a text message or, I don't know, hitting like on a photo.
Exactly. You click, the little wheel spins for a second, and you just assume an email goes out, the customer pays, and everyone is happy. End of story.
Right.
But the source material we are covering today, which is a really fascinating stack of hands-on expert notes from some very high-level SAP SD consultants, it paints a completely different picture.
It's the ultimate deception of the user interface.
Yeah.
Simple on the front, but absolutely chaotic on the back.
And that is what we are unpacking today. We aren't just talking about how to print. That's not the mission here.
No, not at all.
We are talking about bridging this massive gap between the functional configuration, the boxes and arrows, and the hardcore ABAP coding logic. We are solving a logic puzzle.
And it's not just any logic puzzle. The source material we're looking at today revolves around a specific, and I mean specific, complicated change request.
Right.
This isn't some textbook example of set up a printer. This is a real-world scenario where you have a global system and multiple customers with wildly different, often conflicting demands.
Okay, so let's set the scene with the specific challenge from these notes, because it's pretty relatable. We have three distinct characters in this story, and I feel like anyone listening who works in ERP has met these people.
Oh, for sure. You'll recognize me immediately.
First, there's customer A. Let's call them the retail giant.
The dream customer. The one you wish all your customers were. They're low maintenance.
Mm-hmm.
They just want a summarized PDF invoice sent to a generic email address. Invoices@retailgiant.com. Clean, simple, standard.
But then you have customer B, the wholesaler.
Ah, yes. The high-maintenance client.
The tricky one.
The one that pays for your vacation home. They don't want a summary. They want a detailed line item breakdown. They want the invoice specifically in German, regardless of where it ships from.
Okay, that's already getting complicated.
And this is the part that usually breaks standard systems. They need it sent to 3 specific people. 1 in the to field, 1 CC'd, and 1 BCC'd.
Which, as I understand from these notes, standard SAP does not love doing.
It really doesn't. Standard SAP thinks in a very linear way. It assumes 1 partner, 1 email address.
So the concept of a carbon copy or a blind carbon copy is just alien to it.
Pretty much. You have to force it. It hates it.
And finally, we have customer C, the intercompany partner. So this is an internal transfer.
Exactly. They don't need a pretty PDF for a customer. They need an IDOC. That's the electronic data interchange format for system-to-system communication.
But they also want something else.
Right. They also want a PDF copy sent to an internal sales rep, just for their records, for peace of mind.
Okay, so 3 customers, 3 very different needs. And just to make it harder, the notes mention a global exception rule.
The safety net. This is the part the business always asks for at the end of the meeting.
Right. The rule is, if any email bounces for any reason at all, bad address, server is down, sunspots, whatever, a physical hard copy must print automatically at the local shipping office.
Which implies the system needs to be smart enough to know it failed.
It can't just throw an error into the void.
No, it needs to recognize failure, stop what it's doing, switch tracks entirely, and then find a physical printer somewhere in the building.
That is not standard configuration.
Not even close. That is logic we have to build from the ground up.
So our mission today is to walk through how an expert architect actually builds the solution. We're going to go from, the theoretical engine to the functional skeleton, then the technical muscles, and finally the delivery system.
The complete journey, from the database table all the way to the customer's inbox.
So let's start at the very beginning, the architecture. The notes mention 2 main ways to handle output in SAP, something called NAST and then BRF plus O.
Right. And this is a critical choice. Before you even touch a keyboard configuration-wise, you have to know which engine you are driving.
Okay.
The notes are very clear that for most existing ECC systems, and frankly even many modern S/4HANA systems that have been converted, we are dealing with a NAST table logic.
NAST. It sounds like a nasty bit of code, but I assume it stands for something German.
It does. It refers to the Nachrichten status, which basically means message status table.
Okay.
And the transaction code everyone lives in here is NAS. If you're an SAP consultant, NAS is your home base. It's where you define the application. In this case, we'd use V3 for billing and all the rules that go with it.
Now, I hear a lot about BRF Plus being the future, the new hotness in S/4HANA. Why are the experts in these notes focusing so heavily on NAST?
Because of reality. It's as simple as that. BRF plus AS, or Business Rule Framework Plus, is the new S/4HANA output management. It uses these really clean decision tables, kind of like Excel logic. It's very slick.
It sounds good so far.
And it strictly separates the data retrieval from the form rendering. But, and this is a big but, NAST is where the dirty work of deep customization happens.
What do you mean by dirty work?
I mean, if you need to hack the system to send a BCC to a specific person based on, I don't know, the phase of the moon, metaphorically speaking, of course, you're likely working in the NAST framework because the hooks into the ABAP code are just so mature and so well documented. There are decades of solutions built on it.
So effectively, if you have a complicated change request like ours, with dynamic CCs and BCCs and fallback printing, NAST is still the king.
For now, in many systems, yes. It gives us the flexibility to break the rules, which is exactly what we need to do to satisfy customer B. BRF Plus wants you to follow its rules very strictly. NAST lets you bend them.
Okay, so we are driving the classic engine today. Let's move into segment 2 then. Phase 1, the functional configuration. The notes call this the skeleton.
And it's a perfect analogy. This is crucial. The notes emphasize this over and over. If your functional configuration is wrong, no amount of brilliant coding will fix it.
You can't code your way out of bad architecture.
You absolutely cannot. Garbage in, garbage out.
So the first trap the notes mention is the output type strategy. If I have customer A, customer B, and customer C, my first instinct as a novice would be to make output type ZRD1 for retail, ZRD2 for wholesale, and so on.
And that is exactly what you should not do. That is the classic amateur mistake.
Why? What's wrong with that?
It creates a maintenance nightmare. What happens when you get customer D, or when a rule for all customers changes, you have to update 3, 4, 10 different output types.
I see.
The expert tip here is to create one robust output type. Let's call it ZINV for invoice. You use something called the access sequence to handle the granularity.
So one button, but the button is smart enough to know who it's talking to.
Precisely. The logic isn't in having 10 different buttons, it's in having one smart button. And you make it smart using condition tables.
Okay, condition tables. What are those?
Think of them as the if, part of an if-then statement. The standard keys in a condition table are usually something simple, like sales organization and customer number. If sales org is a 1000 and customer is 1 in 23, then use this rule.
But for this complex request, that's not going to be enough.
No way. You might need advanced keys. The notes give a great example. Sales organization plus customer group plus order reason.
Order reason? Why on earth does the order reason matter for an invoice? That seems strange.
Think about context. Why was the order placed in the first place? If the order reason is free sample, you probably want a completely different email template, maybe even a different PDF form, than if the order reason is standard purchase.
Okay. You don't want to send a bill for a free sample.
Or maybe you send a zero-value invoice that's basically a packing slip with a big thank you note on it. The condition table allows you to differentiate output based on the why, not just the who and where.
That makes a lot of sense. And the notes mention something called the exclusive access indicator. That sounds important.
This is a performance and logic saver. The access sequence, the thing that reads the condition tables, searches from most specific to most general.
Okay.
So you might have a rule for customer 123, and then a more general rule for all customers in that country. You set the exclusive flag on the first specific rule. That tells the system that if it finds a rule for customer 123, it should stop looking immediately.
And if you forget that flag, what happens?
The system generates duplicate outputs. It finds the specific rule for customer 123 and keys up an invoice. Then it keeps looking, finds the general rule for all customers in the country, and queues up another invoice.
And you've just spammed your customer.
You've just spammed your customer, and a very angry email is on its way to the support desk. It's a fast way to look incompetent.
Okay, so we have the rules set up with one output type and a smart access sequence. Now let's talk about the processing routines within a NACE. This is where we tell the system how to output the document, right?
Exactly. What to do once a rule is found. For medium 1, which is print, we assign a standard program called RVDN01 and a routine called entry. That's pretty much out of the box.
But our requirements are mostly email.
Right. And for medium 5, which is external send or email, that's where the complexity really begins to pile up. And there's another setting here that's often overlooked. Storage mode.
What's that?
The notes mention this specifically about archive only. If your client uses OpenText or some other optical archiving system for legal document storage, you need to set the storage mode to archive only or print and archive.
And if you don't?
You might send the invoice successfully, but you won't have a legal copy saved in your own system for your records, which would be, a disaster during an audit.
A complete disaster. Now, we have to talk about the partner function trap. This part seemed particularly tricky in the notes.
It is the bane of many consultants. It's a classic problem. Standard configuration usually sends the output to the BP, the bill to party, or the UPU, the payer.
Which is the company, the legal entity.
Exactly. It's invoices@company.com. But our requirement for customer B was to send it to 3 specific people.
Bob, Alice, and Carol.
Right. The requirement is often send to the contact person associated with the sold to. But a big company might have 50 contact persons listed in the system. The standard SAP setup struggles to pick which specific human is the right one for the invoice.
It doesn't know to pick Bob for invoices and maybe Alice for shipping notifications?
It has no idea. It can point to the general role of contact person, CP, but it's not smart enough to say pick Bob's email for the to field, Alice's for the CC, and Carol's for the BCC.
So how do we solve that?
And that's the limit of the skeleton. The functional config can only take us so far. We could enable the partner function CP, but to actually select the correct email addresses and put them in the right buckets. For that, we have to leave the functional skeleton and start building the technical muscles.
We need code.
We need ABAP.
That transitions us perfectly to segment 3, phase 2, the technical architecture. The notes call this the muscles.
Yes. This is where we open the hood and look at the print program.
The driver of the whole process.
The driver, exactly. The standard program for invoices is called RVDN N01. And the source material has a golden rule written in bold, all caps underlined. Never modify RVDN N01 directly.
Why? Is it going to break the whole system?
It might, but that's not even the main reason. The main reason is that when your company upgrades SAP, all your custom changes to standard objects get wiped out. They're just gone.
Oh, wow.
But more importantly, the standard program is rigid. It's built for a simple world. It retrieves data and passes it to a form. It doesn't know how to handle dynamic email body text based on customer groups. It doesn't know how to do dynamic attachment file names.
Right, like ensuring the PDF is named invoice 12345 samsung.pdf instead of just a generic output.pdf that the customer has to rename.
Exactly. All those little touches that make a solution professional. So the first step is always to copy RVDN01 to a Z program, say ZRVDN01.
The Z indicating it's custom.
Yes. This is your playground now. You own this code. You can make it do whatever you want.
And what about the form itself? The thing that becomes the PDF. We hear about SAP script, Smart Forms, Adobe Forms. It's a bit of a jungle.
Well, the notes are very direct here. SAP script is a dinosaur. They explicitly say, obsolete, avoid for new change requests. It's ancient text-based tech.
Rest in peace, SAP script.
Indeed. Smart forms are much more common and they're robust, but they're very layout-focused. The modern standard and what you should be using for anything new is Adobe Forms, also known as SFP.
Why are they better?
They support interactive features, much better design capabilities, they're XML-based, and it's just where the industry is heading. It's the modern tool for the job.
Now, here is a strategy point from the notes regarding the forms themselves. Just like we didn't want 50 different output types, the expert strategy says, do not create 10 different forms.
Correct. You don't want a form for retail, form for wholesale, form for Germany. That is a maintenance nightmare.
Because if the company logo changes,
you have to update 10 different forms, and you will forget one, guaranteed.
So what do you do instead?
You create one master form, one single intelligent form, and you use pages or windows or subforms inside that master form that can hide or show themselves based on a flag that we pass from our new Zprint program.
A flag? What do you mean by a flag?
Just a signal, a piece of data. The print program does the thinking. It says, hey, this is for customer group 01 and the order reason is free sample. It passes that information to the form.
And the form reacts to that.
The form receives that and says, okay, for group 01, I need to hide the discount column. And because it's free sample, I need to show the big thank you banner on page 2. It's dynamic. It's modular.
I love that. It's building intelligence into the document itself. Okay, so we have the skeleton, which is the config, and we have the muscles, the Z program, and the form. Now let's get into the deep dive of the logic. This is segment 4 in our outline. We need to solve those specific customer requirements we mentioned at the start.
Let's do it. Let's tackle requirement A. different email IDs, the dynamic recipients for customer B.
The problem, as you mentioned, is that standard SAP just picks one email from the master data and calls it a day.
Right. So in the entry routine of our new ZRVDN01 program, we have to insert our own custom logic.
Yeah.
The first thing we do is fetch the NAST table line for the current output. This gives us the key to the castle,
Which is?
the OBJKY field. It's a cryptic name, but it contains the invoice number.
And once we have the invoice number,
We can read anything we want. We query the billing header table, VBRK. For values, we query the partner functions table, K and VP. But here's the trick for the complex rule, for the CC and BCC. We look for a custom Z table.
a Z table, you mean a database table we build ourselves?
Exactly. It's a custom table we create just for this purpose. Let's call it Zmail rules. The beauty of this is that the business can maintain this table directly through a simple transaction.
Oh, so IT doesn't have to get involved every time an email address changes.
Precisely. The business can go into this table and create a rule. If customer is 1,000, A&D sales org is 1,000, then TO is Bob at test.com, CC is Alice at test.com, and BCC is Carol at test.com. Our code just reads this table.
So we are bypassing the standard address book entirely and using a custom lookup list.
We're augmenting it. But now, how do we actually handle the CC and BCC part? Even if we get the addresses, SAP doesn't know what a CC is. The notes call this the CC and BCC hack.
Hack sounds exciting, a little dangerous.
It is, in a good way, because standard address doesn't support CC/BCC easily. You have to seize control of the sending process. You use something called the Business Communication Services, or BCS. It's a set of classes in ABAP, specifically a class called CLBCS.
What does that do?
Instead of letting the standard program say send at the end, we tell it to stop. We suppress the standard send command. Then we instantiate or start up this CLBCS object. It gives us total granular control over the email.
So you're building the email from scratch in the code.
You're building the email object from scratch in the background. You tell it, here's the subject, here's the body. Then you call a method like a recipient. And that method has a parameter called iCopy. If you set iCopy X, that recipient becomes a CC. If you set iBlind copy X, it's a BCC.
That is clever. So you are manually constructing the entire email envelope in the code?
Yes. And then you attach the PDF we generated, and at the very end, you tell the BCS object, okay, now you can send it. You've completely taken over the process.
Okay, that solves Customer B's recipient problem. Let's look at requirement B. Different languages. They wanted their invoice in German.
Now, normally, SAP defaults to the customer master communication language. If the customer is in the US, it sends English. If they're in France, it sends French.
But the requirement here is tricky. The HQ is in Germany, but the project team receiving the invoice speaks English. Or the other way around. The default is wrong.
So we need to override the default. The specific technical field that controls this is NASPRAS. SPRAS is the language key. In our print program, before the form is called, we can literally just force change this variable in the code.
We can just say NASPRAS equal E for German.
We could. But a better way is to make it dynamic. The notes suggest checking a custom Z field in the sales order header, something like VB8 Zlang. Maybe the sales rep who enters the order also flags it as project language, German.
I see. So the data from the order drives the language of the invoice.
Exactly. Our code reads that flag from the sales order and swaps the NASPRAS variable to DE just for this one output.
But there is a big warning here in the notes, a critical check.
Oh yes, the SE63 trap. This gets a lot of junior developers. You can tell the code to print in German all you want, but if the Smart Form or the Adobe Form itself hasn't actually been translated in transactional S63, the system will panic.
What happens then?
It will either revert to the original language, which is usually English, or worse, it will just fail completely with a cryptic error. You have to translate all the labels. Invoice number needs to become Rechnungsnummer.
So you have to make sure the code logic and the translation data are perfectly aligned.
They have to be in sync, or it's useless.
Moving on to requirement C. Different formats. We have a PDF versus the email body text.
This is a distinction that confuses a lot of people. The PDF is an attachment. The email body, the text that says, "Dear customer, please find attached your invoice for," is often HTML. It's a separate object.
In the notes say that even if we are using modern Adobe Forms for the attachment, SAP often uses SAP script for the body. Is that right?
Yes, the ghost of SAP script returns to haunt us. For historical reasons, SAP often uses SAP script text objects for the email body, even with Adobe Forms attachments.
So how do you manage that text?
You can set static text in a transaction called SOTIs. But if you want it to be dynamic, to say, dear customer name, you use another transaction, SO10, to create a text object with variables.
And these variables work like placeholders.
Exactly. You write your email template in SO10, and you put in a placeholder like dear and VBDKR name E1 in. The system is supposed to replace that variable with the actual customer name at runtime.
Supposed to. I sense a catch.
The catch is that you have to make sure your Z program actually calls the right function module, usually read text, to perform that replacement. If you forget that step, the email will literally say, dear NVBDKR name E1, which looks incredibly unprofessional.
And what about the subject line? The default invoice 900-00001 is so boring. We want something descriptive like invoice 900-00001 Apple Inc.
Standard SAP is boring. To spice it up, we have to find and modify a specific field in the NAST table structure within our program. The field name is NAST TD Cove Title.
That is a mouthful.
It stands for Title of Covered Output, or something equally German and technical. You use a concatenate statement in the code. You stitch together the word invoice, the invoice number from VBRK, a dash, and the customer name, and you shove that final string into the TD Cove Title field.
And that becomes the subject line of the email.
That becomes the subject line.
It's amazing how much manual stitching is required for something that looks so seamless and automatic to the end user.
That is the job. That's the whole game, making the complex look simple.
So we have built the logic. We have our recipients, our languages, our subject lines. We hit the execute button. Now we enter segment 5, phase 3, email configuration. This is the basis side of things, right? The system administration part.
This is the plumbing. You've built a beautiful faucet, but now you need to know where the pipes go.
The notes mention a transaction code, SAPSDTOP.
So it is SAP Connect. It's the central post office for your SAP system. When your program says send, the email doesn't go straight to the internet. That would be too risky and inefficient.
So where does it go?
It goes into a queue in SOC. It's like digital outbox for the entire system.
And it just sits there.
It sits there until a background job, usually a program named RSCANN01, runs. This job is the pulse of the system's email capability.
How often does the pulse beat?
The basis team usually schedules it to run every 5 or 10 minutes. This is really important for troubleshooting. If a user calls you, panicked, and says, I generated the output, but the customer never got the email, the first place you look is Skottkrider, or SOST.
SOST being the transmission request monitor.
Right. It might just be sitting in the queue waiting for the bus, so to speak.
Or the bus driver. The background job is on a break or stuck in traffic.
Exactly. If that job isn't running, for some reason, no email leaves the building, period.
Now let's talk about the sender identity. By default, if I click the button to generate an invoice, the email comes from me, from john.doe@client.com.
Which is unprofessional for an automated invoice. And more than that, what if the customer hits reply with a question?
It goes to John Doe.
And what if John Doe is on vacation for 2 weeks?
Yeah.
That reply is lost in his inbox. Customers expect a functional mailbox, like no reply invoices at client.com or billing@client.com.
So how do we mask the sender? How do we make it look like it's coming from that generic address?
It's a two-step process. First, the functional step. The basis team creates a generic user ID in SAP that is tied to that billing@client.com address. Second, the technical step. In that BCS logic we talked about earlier, the CLBCS class, there is a method called setSender.
And you just tell it who the sender should be.
You explicitly tell the system, I know John Doe clicked the button, but I want you to pretend this email is coming from the generic billing user. You override the default sender.
It's digital ventriloquism.
Perfectly put. That's exactly what it is.
All right, so we have built it, configured it, and plumbed it. Now for the moment of truth. Segment 6, Phase 4, Testing and Troubleshooting. The notes call this the Expert Toolkit.
This is what separates the juniors from the seniors. When it breaks, and believe me, it will break, how do you find the crack in the system?
Okay, let's take a scenario from the notes. Scenario 1. The output type ZINV isn't appearing in the billing document at all. I go to the invoice and transaction VSO3, look at the output screen, and it's just blank. Nothing happened.
Okay, so the system didn't even try to create the output. This is a determination problem. You need to use the determination analysis.
Where do I find that?
You go into the invoice and change mode, VS02. Then you navigate to the output header screen, and there's a menu path. Go to determination analysis. It's like an X-ray for the logic.
And what does it show me?
It gives you this beautiful tree structure with traffic lights. Green lights mean a condition was met. Red lights indicate failure, and it will tell you exactly why. Access not found because order reason was blank. or requirement 007 not fulfilled. It shows you every rule it checked and exactly why it said nope.
That is incredibly useful. It takes the guesswork out of it.
Completely.
Okay, scenario 2. The output appears on the screen, but the light next to it is red. It tried to process and failed.
This is a harder problem because the determination analysis won't help you here. The logic was found correctly, but the execution of that logic crashed.
It's a code problem.
It's a code or data problem. You need to debug the print program.
But how do you debug a background process like printing or sending an email? You can't just step through it from the invoice screen.
No, you can't. And this is the expert technique from the notes. First, in the invoice, you find your failed output, and you change the processing mode to 1 or 2, which means process again in the background. Then you go into the ABAP editor, and you place a breakpoint in your Z program code.
Okay, breakpoint is set. Now what?
And here's the key.
Mm.
You don't use the invoice screen to re-trigger it. You go to transaction SE38, and you run a program called RSNAST00.
RSNAST00.
Correct. You feed that program your invoice number and the output type ZINV. It acts as a processing simulator. It will pick up your failed output, trigger the code from the beginning, and it will hit your breakpoint.
And then I can step through the code line by line.
And see exactly where the PDF rendering failed, or where the email address variable was empty, or why the BCS object crashed. It's the only reliable way to debug output processing.
That is a pro tip right there. Let's do a speed round on some common errors mentioned in the notes. I'll give you the error, you give me the likely cause.
Let's do it.
Okay, error message. Protocol indicates processing failed.
That's the most generic and annoying one. Check the processing log in VS02. 90% of the time, it's a missing email address in the customer master data, and the program didn't know how to handle it.
Next one, archive not created.
2 things to check. First, the storage mode setting in SAL. Make sure it's set to archive. Second, check the connection to the archive itself in transaction OAC0, the content repository. The link might be broken.
Okay, error. OTF PDF conversion failed.
That's almost always a device-type issue. The virtual printer you assigned in the configuration, probably something generic like LOCL or LP01, doesn't support a font or a code page you used in the form design.
And the last one. Email is received, but there's no attachment.
That's a pure coding error. In your BCS code, you call the add attachment method, but you probably use the wrong binary type. You need to explicitly tell it the attachment is a BYN or PDF type. Or, even more common, you forgot to convert the form's native OTF format into a binary string before trying to attach it.
Fantastic. This is a great troubleshooting guide. Now, let's wrap up with the final segment. Advanced edge cases. The notes call this the top 1%. This for the super users and the architects.
These are the requests that make you sweat a little bit when they come in.
Case 1. Conditional PDF merging. The business says, when we send the invoice, we also need to attach the signed proof of delivery, or POD, to the same email.
This is heavy lifting. The POD is usually an image like a TIFF or a PDF that was scanned and stored in a content server.
It's a completely separate document.
Completely. In your print program, you have to use archive link function modules to find and retrieve that archived image. You bring it into your ABAP program's memory, you convert it to a binary data stream, and then using code, you have to stitch it into the same data stream as the invoice PDF so it arrives as one attachment. Or, more simply, add it as a second attachment to the same email using CLBCS.
That's pure ABA wizardry.
It is. It's not configuration, it's pure development.
Case 2. Validating email syntax.
Users are human. They do data entry. They type john.do@client.com with a comma instead of a dot. The email goes to skix.auth, fails, and creates an error that someone has to manually fix.
So we need a spell checker for email addresses.
We need regex regular expressions. You can put a validation rule in the print program. Before it even tries to send the email, it runs a quick check on the email address string's format.
And if it sees a comma where a dot should be,
it stops. It doesn't even try to send. It can log a specific error in the invoice's processing log saying, invalid email format for partner CP. It prevents the downstream technical failure by catching the upstream user failure first.
That's proactive. I like it. Okay, last case. Value-based suppression. The finance department says, don't send an invoice if the total value is less than $5. It costs us more to process it than it's worth.
That's a very common request.
Yeah.
You don't want to spend money invoicing a 2-cent variance. For this, you use a special tool called output requirements. The transaction is V27.
Well, what does that do?
You write a tiny piece of ABA code, routine, let's call it routine 901. And in that routine, you put one check.
What's the check?
It checks the net value of the invoice from the VBRK table. BBRK net WR. If that value is less than 5, it sets a system return code variable, SYSUBRC, to 4. That's a magic number.
What does SYSUBRC4 do?
It tells the output determination process, requirement not met. Stop. Do not propose this output at all. It filters it out before it even gets created. It's the most efficient way to handle suppression.
It keeps the system clean of junk outputs.
Exactly.
We have covered a massive amount of ground today, from the NAS table all the way to regex validation. The notes end with what they call a final philosophy for the hands-on expert.
And this, to me, is the most important takeaway of the whole thing. The complexity isn't really in the configuration. I mean, anyone can follow a guide to set up an output type.
Right.
The real complexity and the real value of an expert consultant is in data integrity and exception handling.
The notes have a great quote. Always assume master data is missing.
Always. You have to code defensively, assume the email is missing, assume the email address is typed incorrectly, assume the mail server is down, and then you code a safe fallback for every one of those scenarios.
Like our if email fails print rule.
Precisely. If the email address is missing in the Z table and missing in the customer master, what should the program do? It shouldn't crash. It should automatically switch the medium from 5 email to 1 print and send it to a default local printer.
So the invoice gets out one way or another and the business process doesn't stop.
Exactly. That's what turns a complicated change request into a resilient, stable enterprise solution. You are not just building a feature, you're building a safety net for the business.
That is a powerful way to look at it. It's not just about making it work when everything is perfect. It's about making it still work when things inevitably go wrong.
That's what they pay us the big bucks for.
Well, there you have it. The deep dive into advanced SAP output determination. We hope this bridged that gap between the functional requirements and the nitty-gritty technical reality for you. We covered the architecture of NAST, the skeletal configuration of output types and access sequences, the muscular development of print programs and forms, the deep logic of dynamic recipients and languages, the plumbing of Scott, and the expert's toolkit for debugging.
It's a fascinating, complex world under the hood of that one simple send button.
It really is. Now, here is a final thought for you to mull over. We talked a lot today about sending emails and printing PDFs and archiving documents. But as we move toward pure digital integration, EDI, XML, maybe even blockchain invoicing, how much of this document-based logic will survive? Will we still be formatting pretty PDFs in 10 years? Or will the invoice just be a direct data handshake between two servers, making even the PDF itself obsolete? Something to think about next time you click send. Thanks for listening.
Goodbye.